1 liter of a mixture, 1 liter of the mixture of carbon monoxide and carbon dioxide is taken. This mixture is passed through a tube containing red hot charcoal, The volume now becomes 1.6 liters. The volumes are measured under similar conditions of temperature and pressure. Find the volume of carbon monoxide in the initial mixture. Yes, tell me. Shall we discuss? Okay. So we have a mixture. We have carbon monoxide and carbon dioxide. Now what is the volume of this? 1 liter. This mixture is passed through a tube containing red hot charcoal. Containing? What is red hot charcoal? What is charcoal? Very good. Carbon. So basically I am talking about the reduction with carbon. So we know that carbon monoxide, when react with carbon, it is passed through the charcoal. We get when carbon dioxide gets reduced with carbon, what you get is carbon monoxide. Balanced? Balanced. Okay. Now, in the initial mixture, let volume of carbon dioxide be x liter, then volume of carbon monoxide is 1 minus x liter, because total is 1. Total is 1. So if one is x, other will be 1 minus x. So according to the reaction, one volume reducing two volumes. Yes or no?
Yes.
Yes. So x volume, because this is x, so x volume will produce 2x volume. Okay. And now a new mixture is there in which I have 2x of carbon monoxide. Yes? Okay. And what about the carbon monoxide? The carbon monoxide will react with carbon. Obviously, this reaction doesn't take place. This reaction doesn't take place. And how much of carbon monoxide do you have? 1 minus x. 1 minus x. So now in the new mixture, you have 2x of carbon monoxide plus this carbon monoxide 1 minus x. So total is 2x plus 1 minus x, which is, and now this volume is 1.6 liters. 1.6 liters. So what is this? X plus 1 is 1. X comes out to be 0.6. But this 0.6 liter is carbon dioxide. You're supposed to find out the volume of carbon monoxide. So this is for carbon dioxide. Now for carbon monoxide is basically 1 minus 0.6, which is 0. This is what we're supposed to do. Clear? Is it clear?
Yes.
Tell me. Since you asked the question based on ideometry, this is the question based on ideometry. Is it clear?
Yes.
Shall we proceed?
No.
Okay. Well done. Yes, Shireen, Manal, is it clear? Anjana, Bhavika?
So, yes, sir.
Okay. Shanmukha? Shall I? Question number 2. kg of nitrogen. 50 kg of nitrogen reacts with 10 kg of hydrogen. Find the amount of ammonia produced. Find the amount of ammonia produced. Tell me. me one more minute. Shall we discuss?
Yes, sir.
Okay. So we have nitrogen reacting with hydrogen to give. Step number 2 is
Balancing.
balancing. Balanced.
Yes, sir.
Then the mass is given, you can find out the number of
Moles.
moles is equal to given mass, which is 50 kg. 50 kg. So obviously you need to change it into gram. So into the part 3 divided by the molar mass, which is 20. For this, we have 10 kg divided by the molar mass, which is 2. Any problem? So this is, what is this? Solve it. 50 upon 28. Tell me what it is. This is anyhow 5000. What is this? 6 point something. Just tell me what it is. 16. What 50 to 1? Tell me what it is. 50 divided by 28. Yes, tell me what it is.
(1.6 into 10 to the power 3).
1 point.
1.7.
Yes, 1.7. 1.7 something. So what is 1.7 again? 8?
Yes, sir.
178 point 17.
1 point. So 1.78 into 1780.
1780 per 2?
Yes.
1780. 1000 है. सही है 1780 सही. मतलब 0 obviously 0 की जगह कुछ होगा but I'm writing 0 as of now. चलो the next step is to find out the what is the limiting reagent.
So upon coefficient.
Yes. So what you will do? Moles upon
Coefficient.
stoichiometry. So this is 1780 divided by 1 and this is 5000 divided by 3. This is 1780 and this is 1666.6. Right? Can you please tell me what is the limiting reagent? H2. H2 is your limiting reagent. Now forget this step. We have to do with the number of moles. Now we do not require what even if it is 1786 or 5, whatever it is, I do not require that. Now, so the stoichiometry is applied on hydrogen because the product is decided by the hydrogen. So can I say that 3 moles producing 2 moles? Yes or no?
Yes, sir.
So 5000 will produce 2 upon 3 into 5000, which is 10,000 upon 3. Yes or no?
Yes.
Yes or no? Now, we have moles. Moles is equal to given mass upon molar mass. Moles is equal to 10,000 upon 3, which is given mass is what you are supposed to find out. And molar mass for ammonia is 17, 14 plus 3. So X comes out to be 17 into 10,000 divided by 3. Tell me what it is. So this is 5.6666. Yes? So 5.6. So this is basically, see, X will be 5.66 into 10 to the power 10,000. What it is? 566, and obviously this is 6666. Yes or no? 66 gram. Yes. Or you can also write it 56.67 kg. So A is the right answer. Is it clear?
Yes.
Is it clear? Sure. Write down the next question. .2 molar, 0.2 molar, 100 ml HNO3 solution, 100 ml HNO3 solution is diluted with 100 ml of water, 100 ml of water. Find the new molarity. Find the new molarity, which you also call molarity of dilution. Hydrogen is Lr, absolutely correct. Shrini? Tell me what it is. Shall we? Let's go. Okay. We have HNO3 solution, right?
Yes.
This is my HNO3 solution. The molarity is 0.2 molar. Volume is 100. Now I am diluting it. That means I am adding the solvent. And how much of solvent? 100 ml. So I get a new solution of HNO3 only, where I need to find out the molarity. Okay. And suppose this is M1 V1 and this is M2 V2. Then you know that since the solute is same, that means the solute is same. So what is same? The number of moles. The number of moles are same, because molarity depends upon the number of moles of solute, and since solute is same, because solvent is changing, not the solute. You are adding the solvent. Solvent is changing, not the solute. So can I say that N1 is equal to N2?
Yes.
And you know that molarity is moles upon volume. Moles upon volume. So moles is equal to molarity into volume. So M1 V1 is equal to M2 V2. Let's apply this and find out M2. Tell me what it is. Tell me what it is. 0.1. Okay. What about others?
Says
0.2, 0.1. Anything else? Yes, anything else? Zero point one, 0.2, 0.1. Okay. चलो 0.2, 0.2. देखो फिर भी ठीक है 0.1 0.2 के बीच में ही है ऐसा नहीं है 0.3 M1 कितना है? What is M1? 0.2. V1?
100.
And what you are supposed to find? What is that? V2?
100.
100 के साथ तो dilute किया है 100 उसमें already था before. So total volume now becomes 200. You know volume is extensive property that's additive in nature. Molarity is not extensive. Otherwise आप तो ऐसे ही लिख देते जैसे for example if I take a solution, if I take a solution, I say that I have M1 V1 and I have another solution of the same solute M2 V2 and I'm mixing them and I need to find out the final molarity, that is molarity of mixture. Then if it would have been extensive, तो आप ऐसे ही बोलते हैं M1 plus M2 is M3. But no, it is an intensive problem. But volume is extensive, it's additive in nature. So that we have done. And obviously it's a common sense. 100 was already present, now you are diluting it with the same solvent. So 200 and say 0.1 आएगा. 0.1. देख लो ना. ठीक है? Is it clear? Yes. Yes. Yes, it is 0.1. Next question. Question number 4. I'm giving you the element X. Okay. X with the mass 200 and its percentage composition is given to be 90%. Then I have X 201 with percentage composition 8%. And finally I have X202 that is 2%. These are the isotopes. So what you are supposed to find out, find the average atomic mass of X. Find the average atomic mass of X. Find it out. Find out the average atomic mass.
200.12.
200.12. जल्दी कर दिया. Easy है. Shabi, one more time. 1 minute. Yes, tell me what it is. Chalo, look here. So average atomic mass, this is simple. Average atomic mass is equal to the mass into its percentage, into its abundance, natural abundance, which is 90%. Okay. Plus 201 into 8 plus 202 into 2 divided by, because this is percentage, dash KMU will be the answer. Tell me what is 200.1? 200.1. Clear?
Yes.
Clear? Next question. Shall we? थोड़ा सा difficult. The ratio of mass percent of mass percent of carbon and hydrogen of an organic compound CXHYOZ is 6:1. Is one molecule of the above compound. Now this question will test your English. Because this is nothing but just as a social comprehension passage. You should have an art to comprehend this question. So read it twice or thrice because हम ये बोलते हैं comprehension passage को read it twice or thrice. If one molecule of the above compound the compound is CXHYOZ contains half as much oxygen contains half as much oxygen is required to burn one molecule of CXHY completely CO2. The empirical formula of compound CXHYOZ is Sure. English test. कौन से बच्चे ऐसे भी हो गए जैसे बाहर जाएंगे एमबीबीएस करने तो वो डिफरेंट इंग्लिश के एग्जाम्स देते हैं IELTS TOEFL comprehension आके TOEFL चलो think about it. Yes, Shireen, Gayatri, Mana, tell me. मेरा थ्योरी का पेपर होता था आपको तो ऐसे नहीं होता बोर्ड्स में मिलते हुए अच्छा हाउ वाज योर बोर्ड्स रिजल्ट
सर मेरे 100 में से 80 थे केमिस्ट्री
नहीं द
सर ओवरऑल रेट 80%.
80% दिस ईयर होगी ना
यस सर
हाँ.
दिस ईयर.
Yes. 82 80 95 Yes, Shireen, Manal, Gayatri, Devrit, Bhavika, Anjana. Acha, yeah, I think Devrit, so I have asked.
Just a second.
सर
Yes.
इसको मेरे को होमवर्क भी दे दो.
Yes, tell me. Okay, shall we? Shall we? Acha, now I'm reading it once for you. The ratio of mass percent of carbon and hydrogen of an organic compound CXHYOZ is 6:1. Carbon and hydrogen. We do not know about oxygen.
डी है क्या सर?
D. कैसे?
Sir, option D.
Option D.
Maybe. Option D.
D for Denmark. Okay. See. Alright. If one molecule of the above compound, चलो मैं ऐसा बताता हूँ. If one molecule of the above compound CXHYOZ contains half as much oxygen, इसमें half as much oxygen है, which is required to burn this molecule completely. चलो. तो पहले हम वही वाला molecule ले लेते हैं. अब ये देखो आपको कल ही बताया था ये general reaction. याद है?
यस सर.
Yes or no? The general reaction. So देखो, one molecule of this. So can I say one molecule of CXHY producing how many molecules? X plus Y by 4 molecules of oxygen. Yes or no?
यस सर.
Molecules of oxygen. Is it clear? But in the question, it is half as much oxygen. Basically, this is atom, not molecule. So, can I say that one molecule will require twice into X plus Y upon 4 oxygen atoms? Yes or no? Because in one oxygen molecule, there are 2 oxygen atoms. So, can I say twice of this? Yes, chalo, is that right? And इसका half is इसमें. So can I say that जो Z है, जो वो Z है, वो है इस पूरे का half. इस पूरे का. Yes or no? ठीक है? इस पूरे का. Which is X plus Y upon. तो Z की वैल्यू क्या आ गई? X plus Y upon. अब देखिए. आपको X is to Y का mass percent given है. Mass percent, which is 6:1. ठीक है, carbon is to hydrogen, right? But हमें mass percent से मतलब नहीं है, हमें किससे मतलब है? Mole percent. किससे मतलब है? तो ये तो mass percent है. Mole percent निकालने के लिए क्या करूँगा? Divide कर दूँगा molar masses से. अरे mass को molar mass से divide करते तभी तो mole आता है. तो 6/12 1 upon 1 तो कितना आ गया 1/2 रेशियो 1 और 1 रेशियो तो C/H की मोलर रेशियो कितनी आ गई 1:2. तो कैन आई से दैट X is equal to 2Y.
तो मैंने इतना ही करके आंसर हो गया था क्योंकि ऑप्शन ऐसे ही थे.
हाँ मैं ऐसे बना दिया. ठीक है, X is equal to 2Y. आ गया. चलो अब क्या करोगे? हाँ तो बस ये सारी वैल्यूज यहाँ पे रखो इसमें और मुझे बताओ कि Z की क्या क्या वैल्यू है. टेल मी.
सर इसमें ये वाला स्टेप
उल्टा लिख दिया मैंने इसमें. ये उल्टा लिख दिया ना. Y is equal to 2x होना चाहिए.
एक बार ये वाला स्टेप फिर से
ये वाला देखो मास परसेंट्स गिवन है लेकिन हमें मोल परसेंट्स निकालना है. तो मोल परसेंट निकालने के लिए मास अपॉन मोलर मास which is 6/12 for carbon 1/1 for hydrogen which is 1/2 ratio 1:2. या फिर कैसे भी बोलो. देखो अगर इससे ये कंफ्यूजन हो रहा है तो इसको ऐसे लिख सकते हो x/y is equal to 1/2. तो y is equal to 2x. अच्छा अब ये y की वैल्यू है ना 2x, इसमें रख दो 2x और z की वैल्यू बताओ मुझे x के टर्म्स में या y के टर्म्स में बता दो. किसी के टर्म्स में बताओ. देखो x is to y is to z ही तो निकालना है हमें.
Yes.
तो x तो x है ही और y 2x हो गया और z और बता दो बस मुझे कितना है. यहाँ पे रख के 3/2x आ गया. 3/2x. तो देखो ये क्या हो गया 1:2:3/2 और इसमें देखो 2:4:3.
हाँ सर वैसे तो पूरा प्रोसेस इंपॉर्टेंट है पर पहले स्टेप
आ सकता है लेकिन वो मैंने ऑप्शंस खुद बनाए हैं. तो इससे मैंने इजी कर दिया. ठीक है, आपके लेवल पे ऐसे ही क्वेश्चन आएंगे क्या. अगर ऐसा डिफिकल्ट क्वेश्चन आता है तो आपको आंसर्स ऐसे फिर इजी देंगे क्या आप नहीं कर सकते. ठीक है, दिस वाज द फिफ्थ क्वेश्चन राइट.
यस
चलो सो we'll discuss more questions in tomorrow's class. Okay, let us continue with chemical bonding. वैसे भी she said कि homework में दूसरी वाला question. So I think this is okay for the day. Alright. चलिए, let us continue with chemical bonding. So we were doing the VSEPR theory, right?
यस सर.
Yes. A quick revision, a quick recapitulation to what we have discussed in the last class. I said find out the valence electron count. If it is less than or equal to 8, you need to divide it by 2. And if it is greater than 8, divided by 8. And why? To find out the steric number. To find out steric number. All right. Now we will see all the possible cases. Number 1. Here I am writing the geometry. Please make this chart with me. Here I am writing the lone pairs, the bond pairs. Here I am writing the shape or structure, and here I am writing the exam. Okay. All right. The first one. ज्योमेट्री और उससे बाद में एक कॉलम और बनेगा हाइब्रिडाइजेशन. तो यहाँ पे मैं ज्योमेट्री लिख लेता हूँ और यहाँ पर हाइब्रिडाइजेशन. Shall we?
यस सर.
चलिए ध्यान से और नोट पे ध्यान से लगे. ठीक है. Hybridization I am considering Sp. If it is Sp, and I am considering that I have 0 lone pair. Sp का मतलब देखो, Sp का मतलब 2 bond. कितने bond pair?
2 1.
2 bond pair. and shape is very good, linear. See, since I do not have lone pair, then the shape and geometry are the same. So geometry is also linear. What is the example? Let us take the example of carbon dioxide. So see, look here. We have carbon. This is carbon dioxide. Now, how I got this structure? You can use the Lewis dot structure concept. What we discussed in the yesterday's class, right? Now see. Now you will say, sir, you have written bond pairs too, but you have formed four bonds. You know why? Because in hybridization, you do not consider the pi bonds. You only consider the sigma bonds. So there are 2 sigma bonds. That's why we want this. Please remember this concept. Okay. And do you want me to tell how I got this structure?
Yes, sir.
Do you want? Okay. See. So I have N1, N2, N3, N4. What is N1 for carbon dioxide? 4 for carbon, and 2 into 6, right? So 12 plus 4, which is 16. And I have CO3, so this is 24 because all 3 need 8 electrons. Now, 8. Alright. So I have carbon dioxide, write it like this. Take it. Now see. Why I'm writing it like this? That this information I get from VSEPR. So 8 means 4 bonds. 1, 2, 3, 4, symmetrical, and everything is complete. Octet of every atom is complete. The formal charge is a 0. Okay. Now using the VSEPR theory concept, what is the valence electron count? Again, which is 16. 16 means you will divide it by 8. 2 is a steric number which corresponds to sp hybridization, and what about the lone pair? 2 minus 2, which is 0. Simple. This is good. And the information regarding the hybridization, the VSEPR is telling you the hybridization. Simple. Is it clear? Yes. Next. Now I'm not writing those headings again. Okay. उसी के नीचे आप उसी के नीचे करेंगे. Second is hybridization. I'm writing Sp2, 0 lone pair, 3 bond pairs. Shape is trigonal planar. Trigonal planar. Now, since I do not have the lone pair, so whatever is the shape is basically trigonal planar geometry. Example: PM3. So I have. If I ask you what is the hybridization of boron, this is Sp2 hybridized. Boron is
Sp2 hybridized.
And you know this bond angle 120 degree. This bond angle is 120 degree. Clear? Next, Sp2 hybridization only. Now, whenever it is Sp2 hybridization, the geometry is going to be trigonal planar. 1 lone pair this time. So the total steric number needs to be 3. So if I write 1 lone pair, then 2 bond pairs. Total is 3. Still 3. Shape is bend shape. Shape is bend shape. And example, we did it in yesterday's class.
SO2.
SO2. So we have S. Clear? Now this bend shape or angular shape or V shape, whatever you want to write. Is it clear?
Yes.
Next, hybridization. I'm writing Sp3. So the geometry is tetrahedral. 0 lone pair, 4 bond pair. Shape is again tetrahedral because whatever is the geometry is the shape in the case of 0 lone pair. And example, CH4. Then again I am taking the case of Sp3, 1 lone pair, 3 bond pair. Geometry is still tetrahedral, but the shape becomes pyramidal or trigonal pyramidal. Example, NH3. Then we have Sp3, this time 2 lone pair, 2 bond pair because the steric number needs to be 4. and the shape is bent. Example is water. And the geometry is still tetrahedral. Now again, the fourth case of sp3, this time 3 lone pair, 1 bond pair, the shape is linear, and the geometry is still tetrahedral. An example is HCl.
Yes.
Yes?
Yes.
Simple. Clear? Shall we?
Yes, sir. Yes.
Next. Sp3D, geometry is trigonal bipyramidal. Trigonal bipyramidal, which is TBP. 0 lone pair, 5 bond pair. Shape is again TBP. An example is PCl5. Sp3D, 1 lone pair this time, 4 bond pair. This is still TBP. What is the shape and what is
Seesaw.
seesaw? Good. It is seesaw, and the example is SF4. SF4. Then SP. Acha, what is the seesaw shape? Seesaw shape to likh do. S. Slowly. 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 एक यहाँ बैठे, एक यहाँ बैठा. Okay. Sp3D. So it is going to be TBP again. 2 lone pair, 3 bond pair. Can you please tell me the shape? Yes. T shape.
Shape.
T shape. T shape. Example: ICl3. ICl, Cl, Cl. T shape. T. Next. Sp3D, 3 lone pair, 2 bond pair, TBP. Can you please tell me what it is?
Linear shape.
Linear. It is linear. An example? Any example?
CF2.
XCF2? XCF2. So you see XCF2. 1, 2, 3. Clear? Next. अच्छा एक चीज समझानी है, जल्दी लिखो फिर मुझे एक चीज समझानी है. लिख लिया? डन? देखो मैंने बात करी PCl5. ये है मेरे TBP ज्योमेट्री, ठीक है? इसका मतलब पता है क्या? ये वाला क्लोरीन इन तीनों क्लोरीन से 90 डिग्रीज पर है. वो यहाँ दिखा नहीं रखा. ट्राइगोनल बाइपिरामिड. दिस क्लोरीन ये ऐसे है तो ये इससे भी 90. ये तीनों आपस में 120 डिग्रीज पर है, ठीक है? और ये कितना है? और ये भी कितना है? और ये वाला इसी के साथ नहीं, ये वाला इसके साथ भी और इस वाले के साथ. ऑब्वियसली इसके साथ तो नहीं, बट इन तीनों के साथ. तो क्या आप मुझे बता सकते हो कि कौन से वाले क्लोरीन ज्यादा रिपेल कर रहे हैं? ये वाले, क्योंकि 90 डिग्रीज पर कम है. यहाँ रिपल्शन कम है क्योंकि दूर दूर है. यस यस और नो? तो इसकी वजह से ये वाले बॉन्ड्स थोड़े से लॉन्गर होते हैं, लॉन्गर. और ये वाले शॉर्ट. इन वाले बॉन्ड्स को आई कॉल एक्सियल बॉन्ड्स और ये वाले इक्वेटोरियल बॉन्ड्स. ठीक है? इक्वेटोरियल. नाउ अब जैसे कि एग्जांपल अगर मैं XCF2 की बात करता हूँ तो इसमें भी ज्योमेट्री तो TBP है, 3 लोन पेयर है. तो अब मुझे बस यही बताना है कि शेप में ये जो 3 लोन पेयर है ये है ये ज्योमेट्री में. XC या तो ये ऐसे हो सकता है, ऐसे हो सकता है. तो एक पॉसिबिलिटी ये, एक पॉसिबिलिटी ये भी है. कौन सा वाला ठीक है? क्योंकि आपको पता है कि लोन पेयर बॉन्ड पेयर रिपल्शंस आर ग्रेटर देन लोन पेयर बॉन्ड पेयर तो इस केस में यहाँ पर लेस रिपल्शंस है क्योंकि लोन पेयर दूर है, लेकिन यहाँ लोन पेयर 90 डिग्रीज पे है, वहाँ 120 पर है, तो यहाँ पर मोर रिपल्शन तो ये भी याद रखना है। तो इसलिए ये गलत हो गया और ये इज इट क्लियर? एक चीज और है बस। अभी मैंने डिस्कस करा PCl5, वो तो आपको समझ आ गया क्योंकि 5 सारे इक्विवेलेंट है जो कि क्लोरीन है। अगर इस तरीके का मैं कुछ दे दूं PF2Cl3 तब क्या होगा? यहाँ पर एक कॉन्सेप्ट आता है जिसका नाम है बेंट्रो, which says that the more electronegative atom occupies the axial position. इसका मतलब जो इसका राइट ज्योमेट्री होगी, जो राइट स्ट्रक्चर होगा वो ये होगा। ठीक है? Clear? This is better. Yeah. Next. Sp3D2 hybridization geometry is octahedral. Zero lone pair, 6 bond pair. Shape is again octahedral. An example, SF6. Eight corners of the octahedral पर fluorine है, ठीक है? I mean the corners of the octahedral पर fluorine. Is it clear? चलिए next. Sp3D2 में I have one lone pair, 5 bond pair. Geometry is still octahedral. Can you please tell me the shape? Square pyramidal. Square pyramidal. An example is IF5. Next, still octahedral, Sp3D2, 2 lone pair, 4 bond pair. This is square planar. Example is XeF4. Is it clear?
Yes, sir.
ठीक है, done? और एक लास्ट बचा है बस, Sp3D3, which is pentagonal bipyramidal. Zero lone pair, 7 bond pair. It is also PVP. An example is IF7. Is it clear?
Yes, sir.
Is it clear?
Yes, sir.
एक आयनिक वाला, एक आयनिक की स्पीशीज का भी कर लूं? चलो बताओ मुझे शेप ऑफ I3 minus. Tell me, shape of I3 minus.
Linear.
Yes, the first step is to find out the valence electron count, which is 3 into 7 plus this one, which is 22. 22 is greater than 8. This is 6. Then you will divide it by 2. 3 times 6.
Linear shape.
Steric number is 5. 5 corresponds to sp3d. What about the lone pair? It is 5 minus the surrounding atoms. What it is? 5 minus 5 minus 2. एक आयोडीन तो सेंट्रल एटम ही होगा ना, तो दो ही तो बचे सब साइड एटम्स। मैंने भी ठीक हो गया। तो कौन सा केस है? 3
लीनियर वाला।
हाँ, लीनियर वाला कि 2 बॉन्ड पेयर प्लस 3 लोन पेयर। देख लो, ये देखो 2 लोन पेयर, 2 बॉन्ड पेयर, 3 लीनियर। तो ये क्या हो गया? लीनियर। कैसे? I clear? If I ask you what is the hybridization of this? sp3 and geometry? TBP. Geometry is TBP. Structure is shape is clear? Check. Shape is linear.
So,
Yes.
so you just told that electronegative atom occupies the axial position. Can you please repeat that part?
Okay, see. I am saying that if you have something of this sort, PF2Cl3, then I have different side atoms. So, देखो, अब इसमें बहुत सारी possibilities हो सकती है. This is also one possibility. Yes or no? This is also one possibility. So if I ask you which one is the correct structure? Which one is the correct structure? Then this is the correct structure where more electronegative atom occupies the axial position. Now why? Because I told you that because the axial position पर ज़्यादा repulsions होती है जिसकी वजह से वो longer bonds होते हैं. तो longer bonds are occupied by the more electronegative atom. वैसे इसका reason भी है, पर आपको इतना ही याद रखना है. Reason ये है कि देखो हमारे पास है sp3d, right? तो देखो एक बात, मेरे पास 3 equatorial positions है और 2 axial positions, right? Right? So 3 equatorial positions में जो orbitals involved होते हैं वो होते हैं s, px and py. जहाँ पे ज्यादा s कैरेक्टर है, क्योंकि s इन्वॉल्व है तो s कैरेक्टर कहाँ पर ज्यादा है? इक्वेटोरियल पोजीशंस में. ठीक है, s कैरेक्टर इन्वॉल्व है. और जो 2 एक्सियल पोजीशंस है वहां पर मेरा pz और d का कौन सा वाला? dz स्क्वायर इन्वॉल्व है, जहां पर लेस s कैरेक्टर. So according to Bent's rule, the more electronegative atom occupies those positions where the s character is less. ऐसे भी आप समझ सकते हैं. Is it clear, Shri?
Yes, sir.
Okay. Next, let us discuss the valence bond theory. Valence bond.
कितनी टाइम लगेगा उसमें कोड देखना?
Now, what is valence bond theory talks about the formation of a covalent bond. ठीक है. Now, if I ask you, what is a covalent bond? What is a covalent bond?
In which both the atoms are sharing their electrons.
Mutual sharing of electrons. अच्छा. Now, according to VBT, what covalent bond is the overlapping of valence shell orbitals. Valence shell orbitals. The overlapping of valence shell orbitals. देखो. Now, valence shell orbitals of atoms. देखो. अब वो valence shell orbitals होने कैसे चाहिए? Suppose I have atom A. इसका एक valence shell orbital है जिसके अंदर first of all the overlapping of, यहाँ पे एक word मैं introduce कर रहा हूँ, half filled, इसका मतलब है ये, ठीक है, ऊपर ऐसे जो करते हैं ना, half filled valence shell orbitals of atoms. So what it means? It means that suppose if I have two atoms A and B, दोनों के पास half filled atomic orbitals है, और इसका half filled with opposite spins, ठीक है, मैं कंसीडर कर रहा हूँ. So अभी दोनों के बीच में बॉन्ड बन गया. कैसे? दोनों एटॉमिक ऑर्बिटल्स ओवरलैप कर गए तो मेरे पास एक बॉन्ड. ठीक है? Overlapping of half-filled atomic orbitals, valence shell atomic orbitals to form the. This is basically a covalent. But I also discussed with you the coordinate bond, which I said it is a special kind of covalent bond. So see. Suppose if I have an atom A which has empty orbital, and I have atom B which is having a fully filled atomic orbital, So overlapping of these results, still I get a bond like this. Like I told you, once the bond is formed, it is formed. No one is going to ask you whether it is covalent or coordinate. Neither you can tell. But it is just the way of forming a bond. So see what I say, that these two electrons are donated into the empty orbital of this atom, right? And this is basically a coordinate. But a bond is a bond. Once it is formed, it is formed. Clear? Is it clear?
Yes.
Now, let us see what are the different kinds of overlap. So, types of overlap. Types of overlap. Types of overlap. There are two types of overlapping. Along the internuclear axis, and above or below the internuclear axis. See, look here. This results in the formation of sigma bond. This results in the formation of a चलो अब देखते हैं. अब थोड़ा important है, थोड़ा समझ लो लिखने से ज़्यादा. I'm saying this is my s orbital. ठीक है? This is a nucleus. This is my s orbital. This is my internuclear axis. Internuclear, which is passing through the nucleus. Suppose I am taking it. This is my internuclear axis. Suppose I am taking it to be z axis. Now see, if nothing is given in the question, consider z axis to be the internuclear axis. And if it is given that x, you need to consider x or y, then obviously you don't have any choice. Okay. Now, I am saying, and this is s orbital of atom A. Now I am having s orbital of atom. This is s orbital of atom, and this is also the internuclear axis. ठीक है? Yes or no?
Yes.
Now I'm talking about the overlapping between S. Suppose this is 1s, this is also 1s. So let us discuss the overlapping between 1s of A and 1s of B. So see, 1s of A overlaps with 1s of B. And this is called overlapping region. This is called, you know what it means? What this overlapping region means? It means that the electron density is more in this region. Okay? The electron density is more in this region. Yes or no?
Yes.
And this is my internuclear axis. Yes or no? This is the nucleus. This is the nucleus. Z-axis. Now, since this overlapping is along the internuclear axis, I am calling this particular bond to be a sigma. This particular bond to be a sigma. I am considering one unit. Suppose this time I am considering the 2s orbital of A, and this I am considering z-axis to be my internuclear axis, and I am considering this is the internuclear axis, and I am considering the 2px this time. Okay? 2p of atom B. Let us discuss the overlapping between these two. So I have this, and this is overlap with this. Any problem? No?
Yes.
This is my internuclear axis. Now, suppose I take this to be with positive phase. This is for positive and negative. So see, positive, positive, constructive overlapping. Positive, negative, destructive overlap. This means whatever constructive that and in the same amount we have the destructive overlapping. That means overall there is no overlapping. Overall there is no overlapping. So this is no overlapping. No overlapping. Or you can call zero overlapping. Now, zero overlapping. Or you can call it no bond formation. No bond formation. Now you may get confused with this where you will talk about sigma. So this is neither sigma nor phi. Now let me give you a trick where you will form a sigma bond and where you will form a pi bond. See, suppose if there is one loop interaction. S is having only one loop, so SS it is. There's always a formation of sigma. One loop. Two loops. Two loop is a formation of pi. इसका मतलब S orbital can never form a pi because S के पास दो loop होते ही नहीं है. S orbital cannot form
Five.
pi. Cannot form. Four loop भी होते हैं. They will form a delta bond, obviously not in your syllabus. But जैसे कि D and D, four loops है, वहाँ पे delta bond. But आप वो तो इन दोनों से काम. चलो देखिए. अच्छा four loop से confuse मत होना. जैसे suppose एक plane ही है. I have the D orbital like this. ठीक है? और एक plane ले लो. इसमें भी मेरे पास D orbital है. So four loop से मतलब ये है. This one with this one with this one with this. Four loop interactions. So there is a formation of delta. ऐसे four loop. तो हमें तो उन दोनों से मतलब है. चलिए देखते हैं. अब मैं आपको थोड़ी सी पॉसिबिलिटीज देता हूँ, आप मुझे बताओगे कि सिग्मा बॉन्ड बनेगा या पाई बॉन्ड, ठीक है। S and PX approaching X and PH approaching along X. Tell me very quickly. Sigma bond. Tell me.
Sigma bond.
Sigma bond, pi bond. Sigma. सिग्मा पाई में से है ना, ये नो बॉन्ड भी तो हो सकता है। सिग्मा पाई और नो बॉन्ड भी तो एक है, या तो सिग्मा पाई पाई हुआ नो बॉन्ड भी। बताओ, चलो देखो। अब क्योंकि मुझे एक्स एक्सिस दे दी गई है, इंटरन्यूक्लियर एक्सिस, तो अब z मत कंसीडर करना उसको। ये मेरी एक्स एक्सिस है, इस पर आई हैव s ऑर्बिटल और px, ये प्लस, ये पूरा प्लस था, तो हो गया ना ओवरलैप। और वन लूप है, p का एक लूप इंटरैक्ट कर रहा है, तो दिस इज योर ठीक है, ठीक है। अगर वो ऐसे जो आप कंसीडर करते थे वो तब, अगर वो z एक्सिस है। चलिए, ऑलराइट। s and py approaching along z axis.
तो सर जो पहले हमने z एक्सिस का बोल दिया था, उसके अंदर फिर सिग्मा बॉन्ड होता है कि इसके अंदर दोनों लूप थे ना,
तो सिग्मा बॉन्ड तो वन लूप से होता है।
तो फिर इसमें पाई
किसमें?
जो हमने पहले वो z एक्सिस का बोला,
कहाँ पर? ये
हाँ ये वाला।
अरे s तो कभी पाई बॉन्ड बनाएगा ही नहीं, s में तो एक ही लूप है, ठीक है। ये बताइए सिग्मा, ये सही है,
नहीं
सही।
no bond. This is my s. First of all, this is my internuclear axis, which is z axis, and suppose py is this. So obviously there is no bond. There is no bond. क्योंकि s तो कभी पाई बॉन्ड बनाएगा ही नहीं, और p ऐसे है, z एक्सिस है ना, इस बार y एक्सिस नहीं है, इस बार z एक्सिस। देखो ना वो लिखी हुई है, अगर नहीं लिखी हुई तो z कंसीडर कर लो, बट अगर लिखी हुई है तो वही कंसीडर करोगे जो दी हुई। चलिए नेक्स्ट, px and px along x axis. चलो tell me px sigma सिग्मा, अब ये आप कंसीडर कर रहे हो x, ये आपका px, ये है, ठीक है। चलो अब बताओ, px and py along z axis,
नो बॉन्ड।
अच्छा रुको, px and px करो इसको, px and px along y axis,
Pi bond.
pi bond. Suppose this is my y axis, so I have px and I have px. Above and below the internuclear axis, this is the pi bond. Next, px and py along z axis. Px and py along z axis. Yes. Px and px along z axis. नो बॉन्ड सिग्मा बॉन्ड
या तो सिग्मा होगा या तो नो बॉन्ड।
और पाई
सिग्मा
सिग्मा
एक्सेट सिग्मा
बॉन्ड नहीं होगा सिग्मा नो बॉन्ड।
ऐसे थोड़ा आंसर दिए जाते हैं।
कंफ्यूजन बता दे।
नो बॉन्ड से नो बॉन्ड।
नो बॉन्ड और सिग्मा बॉन्ड और पाई बॉन्ड।
पाई तो
पाई तो नहीं होगा।
पाई नहीं है।
पाई नहीं होगा?
नहीं
तो क्या? सिग्मा एंड नो बेसिकली। पाई कोई है? अगर पाई हुआ तो देखो ये क्या है? जरा एक्सेस ये क्या है? एक्स ले लूं इसे
हाँ सर।
और फिर इसको वाई लेना पड़ेगा। ठीक है? आप बता सकते हो। ये दोनों आपस में नहीं करेंगे।
सर परपेंडिकुलर भी होंगे तो भी मतलब ओवरलैप।
यस देखो इसके लिए अगर पाई बॉन्ड के लिए कोई ऐसा होना चाहिए था यहाँ पे ताकि ये ऐसे कर ले। यस बताएं और इसके लिए कोई ऐसा होना चाहिए था है ना ताकि ऐसे कर लेता बट क्योंकि ये है नहीं तो इसका मतलब यहाँ पे क्या हो गया
नो बॉन्ड
जीरो नो बॉन्ड ठीक है आ गया चलिए अब क्योंकि हमने ओवरलैपिंग तो देख ली ओवरलैपिंग तो हमने देख ली अब हम देखते हैं एक्सटेंट ऑफ ओवरलैपिंग किस में ज्यादा ये तो देख ली कैसे होती है ओवरलैपिंग अब किस में ज्यादा और किस में कम हमने देखी कितने टाइप की होती है सिग्मा पाई अब किस में ज्यादा और किस में कम देखो जब मैं बात करता हूँ एक्सटेंट ऑफ ओवरलैपिंग की एक्सटेंट ऑफ ओवरलैपिंग तो आपको दो फैक्टर्स कंसीडर करने हैं देखो along the differentials या फिर in differentials among the differentials and among the same shell देखो अगर along the differentials है so जैसे फॉर एग्जांपल 1s और 1s के बीच में ज्यादा ओवरलैप अच्छी ओवरलैपिंग होगी देन 2s देन 3s तो साइज पे डिपेंड करता है छोटा साइज बेटर ओवरलैप क्योंकि देखो ना छोटे s हो गए तो ये एरिया सिग्निफिकेंट होगा बड़े s हो गए तो ये वाला एरिया इतना सिग्निफिकेंट नहीं है ना छोटे में ज्यादा इलेक्ट्रॉन डेंसिटी आ रही है तो 1s में ज्यादा अच्छी ओवरलैपिंग है देन 2s और 3s में और अगर among the same shell है तो सबसे ज्यादा P में होगा देन S में देन D में देन F इनमें तो समझ आ रहा है क्योंकि डिफ्यूज नेचर है मैंने बताया था काफी खाली स्पेस है इलेक्ट्रॉन डेंसिटी बहुत डिफ्यूज्ड है तो अच्छी ओवरलैपिंग होगी इन दोनों में क्यों ऐसा क्योंकि देखो S में नॉन डायरेक्शनल है S में यहाँ से भी हो सकती है तो S तो होगी नहीं मतलब S में S मतलब यहाँ नॉन डायरेक्शनल है ना कहीं से भी हो सकती है लेकिन P आपका डायरेक्शनल है अगर ये पॉजिटिव है और ये पॉजिटिव है तो यहीं से होगी इधर से नहीं हो सकती यस और नो तो यहाँ क्या है ड्यू टू डायरेक्शनल नेचर ऑफ P में ज्यादा अच्छी ओवरलैपिंग होती है एज कंपेयर टू S याद रखना लेकिन among the same shell है ये अगर 2s 2p 2p आ जाए तो 2p 2p में ज्यादा अच्छी है देन 2s 2s along the same shell बोला है ठीक है फिर थैंक यू सो वेरी मच